the number that's not on the screen because I couldn't squeeze it in when I put this together. It's 949-282-0123. That's 949-282-0123, and anybody can help you out. And also, if you didn't write that down, it's on the email that sent out yesterday afternoon with copies of presentation materials. Also, if you're tuned in and you weren't on the pre-registration list and you did get copies of the presentation materials, just send us a little note after the webinar, and we'll be glad to send those to you. Okay, so I guess without further ado, let me go ahead and talk about our key topics for today's webinar that's dealing with audit techniques for the SEMS program. The main things we want to do are give you a little regulatory driving forces. A lot of you in industry have companies that have onshore facilities. There are a lot of resources that you may have internally that you may not know about. I want to go ahead and draw some parallels between the SEMS requirements and other regulatory requirements. I want to go ahead and talk about specifically our focus for today, which is auditing. Really focus on tips, practical approaches to addressing the audit requirements, and organize an effective SEMS program. And also at the end, there's a lot of references, resources, coming up webinars, and courses that will be helpful as you pull your SEMS program together. So let's talk about what we're doing here. What's driving all this? Let's go ahead and get the whole thing on the screen. There have been a number of unfortunate tragedies that have occurred as we move towards more technology dealing with lots of energy sources. We're having an audio issue. Well, let's switch out mics then. Excuse just for a minute. Is the audio issue solved? I apologize to the honors of checking this out. Okay, it's good to have you back with us. So over the course, as we as people deal with more and more complex technologies, higher energy sources, deeper wells, more extreme conditions, there's a lot of potential consequences associated with our activities. And there have been many tragedies that have been reminders that as safety professionals, which I think a lot of people who are participating today are, is there still a problem?
Apparently. I can hear it okay through my father, but Ryan says people are complaining and he doesn't get any better. I don't hear it. I can hear it okay.
All right, we're going to take 60 seconds to, I'm told some of the participants are having difficulty with their audio. What I'd like to do is go ahead, Solveig, do you want them to identify themselves on your chat window and audio problems?
That would be nice.
All right, if you can hear, well, of course, the people who are having problems can't hear me, but if you're having problems or it's sporadic or spotty, go ahead and send our producer a little note on the chat window, and then we'll see if we'll try to go ahead and troubleshoot that. Sometimes what happens, there's bandwidth problems over the network. So anyhow, I'm going to go off mic for 60 seconds while we troubleshoot on our end. And again, please make a note on your chat window if you've had any audio problems. issue, and it's probably more associated with the WebEx function. I think people calling in on the phone lines. My guess is that if you're using a computer, you're probably in good shape. Anyhow, as we move forward, if you do have any technical problems, please do use the chat window or call in, and we'll be glad to get somebody assigned to help you out. Okay, tragic reminders have made safety professionals realize the importance of their work, the potential consequences associated with their facilities, and the real need to maintain a high level of safety at different facilities. This next slide identifies a lot of the key events that have happened over the past few decades. The ones in red are ones that have actually precipitated significant changes in our regulatory paradigm, and a movement towards, in many cases, from prescriptive-based safety regulations to performance-based regulations, like PSM and RMP. And so let's talk about some of those driving forces so we understand where we're at and what our key objectives are. When you look at a lot of these major accidents, they certainly cause a significant loss of life and property, as well as significant indirect costs, business interruptions, lost confidence in contracts, increased regulation, and also characterized by relatively simple precursors. A lot of these weren't gaps in our knowledge of technology or new laws of physics or things like that. They're really simple precursors and fairly straightforward initiating events, sometimes several things happening at once that most people weren't expecting. A lot of times, things that appeared to be happening at once, but a lot of times you had covert failures or failures that had occurred that people just hadn't addressed through their maintenance program and other management issues. So when you look at the root causes of a lot of the major events that have occurred in the past, they're really a failure to maintain the design intent, which is your first line of defense for protecting against releases, fires, explosions, things that can result in personnel injury, impact on the environment, and also major equipment damage. So when people took a really good look at this, and especially after a lot of the major events, the major tragedies that had occurred over the past decades, they realized that the most effective mechanism for improvement wasn't by addressing specific actions, but really by affecting changes in the way business is done. And that goes back to safety culture and also management systems. So really that became the focal point for this evolution of prescriptive-based regulations. This is a kind of a busy slide, but I like it. And what it does is it kind of shows the parallelisms in the development of things and when things happen on a timeline, and it kind of gives you some good insights in terms of why they occurred. When you're looking at onshore process safety issues, the real key trigger point, and the photograph is the what's left of the Bhopal facility, part of the Bhopal facility, where there's a serious methyl isocyanate release that killed several thousand people and injured many tens of thousands of individuals. That occurred in 1984. It's interesting that industry responded with the CCPS developing some management guidelines in 1987. American Petroleum Institute came out with its recommended practice 750, again for performance-based regulations, then for performance-based guidelines, and then process safety management and risk management programs, they came about. But that evolution was triggered by the Bhopal accident, and industry reacted first. When you're looking at offshore safety management systems in the United Kingdom, that's the lower arrow. It's really the Piper Alpha event in 1988 that really triggered a lot of understanding of a need for improvement, and it brought about the evolution of safety cases, which were extensively applied in the United Kingdom and in many parts of the world at this point. That was also updated in 2005. Offshore safety management systems in the United States, even though Piper Alpha was certainly a bellwether for the potential for severe accidents and injuries and tragedy associated with those kind of events, there weren't significant regulatory requirements in the U.S. outside of some specific state programs, which Mark Steinhilber will talk about in a little bit more detail in a bit. But basically, there was an evolution of safety instrument systems, the origins of that, with the platform safety shutdown system study that I had the privilege for being involved with in 1990. Safety and environmental management programs, the concept that was introduced by the API in the early 90s, refined in the mid-2000s, and eventually promulgated into regulation in 2010 with the final rule that came out on October 15th. So that evolution was triggered, the original impetus for performance-based guidelines came about because of Piper Alpha. A lot of state programs picked up on that and developed a mechanism for control and working with offshore facilities in the 90s. But it was really the Deepwater Horizon event in 2010 that really pushed it into the regulatory framework for federal waters. And there's a lot more to this in terms of drawing these parallels and understanding the history of that. And what I'd like to do is encourage you that we put together a very nice paper. Well, I thought it was nice. For the Global Congress on Process Safety in Chicago this year. And if anybody would like a copy, it's available on our website. And maybe it's something we can solve if we can send that to the participants afterwards too. They might enjoy that. It provides a lot more background and a lot more details of the SEMS regulations and how they came about. So let's start focusing on the auditing program and looking first at how these different program elements of SEMS compare to other safety management systems. The SEMS program, basically the key provisions for that are safety and environmental information, hazards analysis, management of change, operating procedures, safe work practices, training, mechanical integrity, pre-startup review, emergency response and control, incident investigation, and the focus for today, which will be the audit of the SEMS and SEMP elements. Now, the SEMS requirements actually make a lot of references back to the API Recommended Practice 75, which kind of formulates the SEMP program. So it kind of shows that this isn't really something that's a brand new concept. It's really something that's kind of tried and true. And we'll talk more about that in a few minutes. The circles in red, hazards analysis, management of change, operating procedures, and mechanical integrity, really represent two things. When the earlier versions of the SEMS in 2006 were first put forth as a guideline or rule for comment, those were the key four elements that folks wanted to start with. It's actually the same four elements that are bugaboos for a lot of different facilities, both offshore and onshore. And onshore, they're the kind of elements that have resulted in a lot of fines associated with onshore facilities. The next slide, what I want to do is show you some of the overlap between the process safety management, risk management programs, and also the SEMS and SEMP requirements. If you look at it, the area in green is the overlap area, the things like hazards analysis, auditing, safety and environmental information, training, pre-startup reviews, incident investigation, mechanical integrity, management of change, operating procedures. All those things are significantly overlapped between all these programs. And if this slide even gives you a compliance matrix, it gives you a lot more detail of the specific regulatory citations. And if you look at the key elements of a management system, whether you're looking at an onshore facility or an offshore facility, whether you're looking at oil and gas, whether you're looking at a processing facility, whether you're looking at dealing with hydrocarbons, whether you're looking at dealing with chlorine, ammonia, or any variety of the chemicals in use today that make our modern lives a little bit easier and more comfortable, the same kind of management system elements show up. And these things have been about since even one of the biggest first pushes was in 1987 when I was serving on the technical steering committee for the Center for Chemical Process Safety. It was one of the first guidelines that came out on the on management systems and how to go ahead and implement them. And if you look at that guideline from 1987 to a lot of the modern regulatory requirements at the federal level, which are PSM, RMP, and SEMS, or various programs at the state level, you're really looking at mostly overlap. And when you think about it, you've had thousands of safety professionals over decades looking at these programs, struggling, trying to control and manage safety at their facilities. So the overlap is significant in two ways, in many ways. First of all, it gives facilities, or I'm sorry, companies that have tendrils in onshore and offshore facilities and lots of different business units, additional resources, it also shows you that there's really something there, that the proper implementation of that means that a lot of folks really haven't thought about a lot of new ideas on how to make that better. So element or the core of safety management systems, and that's what is the backbone for SEMS. So let's talk about the audit requirements. There's a couple of reasons why this auditing element is so important, and at the very end I'll bring up to speed with current events and a lot of what the Center for Offshore Safety is doing, a lot of what the OOC is doing with respect to the audit guidelines and why auditing is such a critical issue for the SEMS program. One of the things that's interesting is the SEMS application of auditing is quite a bit different from some of its sister programs. The intervals are the same. The audit is requested every 3 years. For the SEMS program, it's starting on the second year after the initial program completion. That's one of the things that makes it stand out a little bit, and it's a little different. And it's also, the timing is synchronized with the application of the hazards analysis element in SEMS. That's actually addressing a lot of the things that have caused problems in the past with other safety management system programs when you're not synchronizing major updates and evaluations of your program, of your facility, the hazards, and auditing the health of the program. By keeping it on the same schedule, it's a lot easier to manage and keep track of. Another thing that stands out for SEMS is there's a requirement to submit a plan to the DOE-MRE at least 30 days before the audit. After the audit's done, you have to submit an audit report within 30 days of audit completion to the DOE-MRE, and you must have a plan for addressing audit-identified deficiencies. What's been found for some of the other program is a lot of these things tend to lag. A lot of times the audit results were able to be reviewed by the regulators when they came on site. The SEMS program is addressing a problem that has occurred with the things not getting done on what was considered to be a fairly prompt timeline. There's also a big issue that's a requirement for a review that's independent of the program formulation. Basically, whoever formulated the program, whether it be within your company or outside your company, it's got to be a different organization or a different group of people, and you must show that your conflict of interest between the person who developed the program and the person who's auditing them. That doesn't necessarily mean at this point we'll talk more about possible evolution of the SEMS program that's on the horizon, but at this point there's no requirement for third-party outside contractors to audit your program, but there is a requirement that you've taken steps to make sure that it is independent and you've avoided conflict of interest. And in fact, there's an entire section in the SEMS regulations that are dedicated to auditor qualifications. In contrast to that, the PSM and RMP programs only stipulate a very higher superficial level, triennial audits, and retaining the 2 most recent compliance audits. So they don't get into detail on the implementation of action items, getting a plan that's submitted to the regulator for approval prior to you starting the audit. So those are kind of the key differentiated between the 2 programs. Now, I want to stop it there and turn it over to Mark Steinhilber, because we're going to have a 4-day course in October in New Orleans, and we're going to be, for reasons that I'll explain later, really focusing a lot on auditing techniques and how to go and do that properly. And of course, along with that, a more complete description of the SEMS program, et cetera. That'll be a 4-day course in New Orleans in October. And so what we're doing this morning is trying to give you some basic tips and an overview, and that's why I want to keep the description of the audit fairly superficial. So let me introduce Mark really quickly. He's currently with the California State Lands Commission in Mineral Resources Management Division, and he's a supervisor of their safety audit program. So this is somebody who basically does this for a living. He's led the program for 8 years, and they've completed, he and the other members of the project team have completed nearly 2 cycles of safety audits for all the, in the state waters off California, the offshore oil and gas lease platforms and facilities. Mark's background, extensive background with the Coast Guard, And also he's got a mechanical engineering PE from Virginia that he's had since 1988. He's got master's degrees in mechanical engineering and in naval architecture and marine engineering from MIT, and also a BS degree in naval architecture and marine engineering from the U.S. Coast Guard Academy. So let me go ahead and welcome Mark, and he'll be getting into a lot more details and tips associated with the auditing program. And do we have the other mic right yet? Sure, I'll do this. All right, thank you, Mark.
Well, good morning. Thank you, Steve. I think his presentation so far has been right on the money. We're going to get into the different elements, and I'm going to start off with the safety and environmental information. So are we using this to move forward?
Yeah, it works for me.
Okay.
Oh, it's this button right there.
Yeah.
It's the little dongle on that computer.
On the computer.
I know there's a lot of hardware on this.
Okay. So we're going to begin with the 13 elements, and the first is safety and environmental information. You can look at the type of information that you should have on hand in generally 3 categories. One of them would be the basic facility design. With ship designs, we call it the general arrangements. I think we probably see the same thing with MODUs and even jacket-based platform structures. The arrangements drawings give you an idea of the layout of the facility, how many levels there are. It helps you with different design aspects such as built-in structural fire protection, where the major equipment is, and escape routes, access, separation of quarters, and so forth. So that's important information that the auditors are going to need to know before they visit the facility. It gives them an idea of what they're looking at, basically, without having to be on site. Structural drawings. They will need to know when the facility was built and to what design basis or design code it was built. API RP 14J has been around a long time, as have the structural aspects API RP 2 series. And so some of the information as to where you are on that and when the different inspections have been performed is good information to have, but the drawings are really the key for the auditor to get started. Beyond that, as part of the design basis, I spoke about the structural fire protection, which means firewalls, basically passive type protection rather than an active detection or fire main type system, which is a action. And then your safety system design or safety systems on the platform. This would include your fire system, your detection systems, where your emergency escape capsule is or the life rafts, positioning of fire eyes, portable fire equipment, eye wash stations, and so on. Typically, you have a diagram that shows all of that information, and that's a great piece to be able to offer auditors right up front at the initial meeting. One of the ideas is to package this information together. It's likely that your auditors, whether they be in-house, third-party, or from BOMER or the state, they will ask for specific items. It's likely that these are going to be contained in that package. Moving on, one of the big areas for a production platform is going to be your process design information. And that's really why the platform is there and why it has a number of decks. Once the wells are existing, it's the processing equipment that's on board that can cause you problems. That is where you can have a release, and that's where you can have fuel for an explosion or fire. So by looking at the process system and making sure that it's safe, you're going to prevent incidents. How do you do that? You need to have the process design information, which basically comes in three main pieces. Process flow diagrams that show your different streams, how much of each type material is moving through the process, and it also shows where it goes and the major pieces of equipment. That needs with the different process stream information. Beyond the process flow diagram, which gives a basic concept of what you're doing on the platform with your oil and gas production, you will move beyond that and then use P&IDs to actually indicate what type of piping you need to connect your various pieces of equipment. It shows both the control sensors, the control system, as well as the safety system, which on all of the U.S. We're following API RP 14C, and the safety system needs to be a separate system. So for that, you will need P&ID diagrams that show the control system and also the safety devices that are used for those two systems. They tie in with a safe chart, which is basically a function relationship diagram. And in short, it is a cookbook style HAZOP. So you have a bunch of key pieces for SEMS right here in this safety environmental information. As I mentioned, the two main recommended practices. In the state of California, we require RP 14C. Newer platforms we're requiring 14J. We have a bunch of older ones, and our regulations require good oil field practices. And we consider API RP 14J and 14C to be exactly that. And so basically, platforms comply with those two recommended practices. Also based on the date of construction, there may be some existing design that is continued or maintained. So moving on, here's an example of a process flow diagram. Some of the practical approach items are your auditors will be able to look at a process flow diagram, and they will see the main components in your process system. The idea that in this instance, we have, it looks like 4 main pressure vessels. It looks like we have some other type of heat type equipment, and then we have a series of pumps. It looks like some type of heat exchanger and so on. They are starting to form what the maintenance is going to need to cover. So they can make a quick list of pressure vessels and tanks that they see on a PFD, and they're going to be looking for the information that shows that they're being maintained. So you can see that the initial information gives the auditors an idea of what they need to look for. Piping and instrumentation diagram goes into more depth for them. They now see the different safety devices on the piece of equipment, and they're able to, from their training, realize which ones are likely required by 14C just to meet the HAZOP. There's some standard safety devices that we typically always see, and there's some pitfalls that we watch out for. So the P&IDs need to be up to date. They will go looking at them. They're pretty good at taking one and going out on a platform and finding that, oh, a couple of the vessels have been changed, your process is actually different, and this P&ID is not up to date. And so they will then ask the operators if they redlined version on the platform. Hopefully you do, and that's a good thing because you're at least keeping up with it. The modification may have been very recent, but it also has the It also allows them to know that there's been a change, and the change means MOC. So now they have a thread that they're onto where there's been a change. They know that they need to ask for an MOC document for the change. And so they have a thread. They can start following that thread to see if the other related elements of SEMP are implemented and whether or not they're effective. Some of that will go into operator training. Some of it will move over to whether the safe chart has been updated with this information. They will find out if the new equipment is in the maintenance program. And so you start to see that it's sort of a thread. You can find your way through or SEMS, and you will quickly start to come to assessment of the level of implementation. Most companies have an HES department, health and safety, environmental department, and they're all over marine material safety data sheet type programs. They typically have all of the standard EHS, HES type information in line and in a good program because of the liability situation with workers. So have your HES department up to snuff. They can prepare an HES package to go along with your other safety environmental information, and it will show compliance with major pieces of the SEMS. You just need to package these different things together, and not only do you have building blocks, but you also have much of it assembled into a wall or into the program or the complete SEMS that you need. Moving into hazards analysis, I mentioned that the hazards analysis in many of the standard jacket style production platforms is accomplished through a safe chart following API RP 14C. That said, 14C does not look at history per se on your particular platform. It does not look at external events or the particular arrangement or location or situation that you have with that platform. There may be other external events that you need to consider, and in doing that, you may want to run another type of hazards analysis to consider those problems. And with that, do I want to go to Esther? A couple more things on hazards analysis. We typically see the safe chart on our platforms. We also do audits of facilities onshore, the supporting facilities onshore, as well as islands and other types of facilities. A safe chart in API 14C does not necessarily apply to those facilities. It certainly doesn't apply onshore. Companies have used that method to do HazOps many years ago to develop, some of the earliest HazOps for their facility and to come up with their safety system. So you may see something that looks very much like a safe chart for an onshore facility. Sometimes it's called a function relationship diagram. It may accomplish the same thing. We do have situations where the acronyms for the different devices follow an ISA standard. So a level safety high, an LSA, or an LSA, a level safety alarm, may not be a level safety alarm in some of the facilities. If it follows the ISA standard, you'll see that it's a level switch high, and it may or may not complete the functions that you want for a level safety high. So sometimes we have to do a translation and understand what we're working with. Here in California, we accept that. I do not know how BOMER handles that offshore. I believe that they likely prefer the 14C straight up version. With that, next one. This slide shows a little bit of what I'm talking about for hazards analysis. You see kind of right there in the center, the RP14C review is one way of accomplishing at least part or most of the HAZOP for a jacket-type platform. You can supplement it with checklist or what if, or a combined what if checklist style hazards analysis, and you can even marry that up with your safe chart, and so that you cover the other hazards that you've considered. You may, and your history, if you have some incidents that have occurred in over time, you need to have those initiating events or that type of history considered in your hazards analysis. So you may need to bring that in using the what if checklist and pose that question exactly to supplement your safety chart. Some companies have gone beyond that. We see in the UK the safety case type bit of looking at risk with the platforms, and with that type of program, you may be choosing other types of hazards analysis, not the cookbook that's predominantly used in the U.S. So that's some of the things you can see off to the right. If you have a very complicated platform, you may opt for something other than a jacket. You may have a new tension-like platform, or some of the stuff for the deep offshore. You may some of the other risk quantification out to the right to try and control as much risk as you can. So the cookbook style has a pretty good history on the standard shallow water jackets, and I think that history bears that out. We'll move on to the next slide. Management of change. I told you about the are you ready? Is this fine? Okay. Let me catch up here. Okay. On management of change, I talked about our method of finding out where there's been change. When auditors come to platform, they will need to be talking to typically the lead operator and even other personnel that are assigned to the platform, or company personnel that come along with them during the audit. And there's likely to be dialogue. There's the likelihood that they will soon find out some of the history of the platform if it has not been provided. It's typically easy to find where there's been change. You can find new steel. You can find newer style sensors. Where you see a PLC and a bunch of much newer equipment, and then you see old pneumatic type systems on the major pieces, you can tell what's newer, and that may be a way to start looking for management of change. Most companies have been doing the various pieces of SEMS all along. It's basically management of your operation. SEMS is just a set of requirements that tries to tie it together and to help ensure that the balls can drop moving from one to the next. When you have management of change, the management change part of SEMS is trying to make sure that you don't forget to do one of the important functions that you must do when you make a change. Management change intends to look at changes in design, changes in the facility overall, changes to personnel, like going to an unmanned platform or reducing the number of operating personnel on board. Will they have enough time to perform the functions they need to perform? Does the automation make up for the personnel that are going to be removed? So personnel is an important one. It was not necessarily considered part of a change in the past by companies, but in certainly that's been more of a consideration. Even personnel, the difference, what happens with a maintenance crew when they're on board? Do you have different issues going on? That's why it ties in with your permitting type system and your pre-startup safety reviews and so on. And then finally, procedures. Procedures need to be updated. There's relationships between the procedures and training for operators, qualification for operators, and even procedures for maintenance. So it bounces around between the different elements. When you change equipment, you need to update your maintenance package. You need to update your procedures. You need to go through a bunch of the different things that we see within SEMS. And then some of the things that you need to do when you're doing a change. And finally, all follow-up complete. I mean, it's even looking to see that your PFD and your P&ID drawings are updated, your safe chart and training and so on. And then that your design basis is updated. You need to get those corrected drawings and so forth into your safety and environmental information package, your design basis, so that the next time the auditors are coming, you have all the latest prints. With regard to operating procedures, this is something that you're typically, you've had all along. This is the thing that you use to train new operators. This is the thing that the current operators should be reviewing and updating on a periodic basis. Procedures should cover initial startup, such as when the platform is just built. It needs to cover an initial startup when you've had a major change. It should provide all the instructions or procedures for the operators in normal operation. There may be temporary operations that you will do on a periodic basis. You should try and cover those. If you're in a mode where you're flaring and you have to make certain adjustments, and it happens commonly, you should have that covered in a procedure. Emergency shutdown should be addressed. How does it normally happen? What happens when a platform shutdown is hit manually, and what are the responsibilities of the operators once that happens? Do they just go to the meeting site or the evacuation site, or do they have responsibilities to attend to? And then finally, normal shutdown. Normal shutdown may be used prior to a maintenance availability. And how is that done? So that you don't have a release, so that you don't trip safety systems or trip PSVs and so forth. Operating limits. One of the key parts of operating limits is, or operating procedures, is to establish your operating limits. What are the normal pressures and temperatures? What range do they stay within? And this typically reflects where your safety system and also where your control system set points are. Once you know those, you may need to be giving the operators the steps to correct or avoid deviations. And then beyond that, you really need to have consequences of deviation. If there is one thing that they're going to do that could cause a large problem, you need to address that, and it's called a consequence of deviation. If you don't, those in many operating procedures that were developed a long time ago may not have consequences of deviation. The operators, if they sat down and thought about some of the things that they shouldn't do, they can probably come up with a top 10 list of things they could do to cause a big problem on your facility really fast. Those are the 10 you're going to want to start with for a consequence of deviation. If there's one valve that can wreak havoc, that if they close and the system and you're on production, then you need to have that. The closure of this valve will result in, a rapid overpressurization and a flaring incident, and it is likely that the flare scrubber will be overwhelmed with liquid, and you'll get liquid out the flare and it'll be a spill into the water. So those types of things are the ones you want to look for first. Personnel may be able to help you get the top 10 immediately. On other ones, you're going to want to look for ones where an operator doing something is going to cause the process control to go out of limit, and then the safety system will have to respond. So if you can identify some instances where that happens, that would be another set to look for. And then beyond that, you can go through each procedure and look at pretty much any steps. If they're done incorrectly, you evaluate whether it's going to cause the system to go out of limit and whether there'll be a problem. Operating procedures should be reviewed periodically. They need to be up to date. One of the methods that we've seen with companies, and it seems to be a good one, is where they will have the different operators take a procedure periodically and go through it, review it. If they, hopefully there's not a change to it. If there is a change, it shows that perhaps your MOC is not working properly. But they may have some new adjustments that are in there. They may have found that something works better. There may have been subtle changes on the different operating ranges, and there may be some corrections that they put down on that procedure. Once that's done, it should get another level of review to see that that's correct. It should be evaluated whether it should trigger an MOC review to see if it somehow defeats your safety system. There's something incorrect with that modification to the procedure, and you should then get it updated and incorporated into the training. So there's a tie-in between all of the different elements of SEMS. Let's see, moving on to mechanical integrity. This is one of the areas where auditors can find problems or find where a thread starts. Early on, we said that with a process flow diagram in the safety environmental information in your design package that you'll give an auditor, they'll look at that and they may know the number of major pressure vessels, tanks, and large pieces of equipment that you have at your facility. They may have a list of items all prepared that they are going to pick and choose from to see if the maintenance is up to snuff. One of the things that I brought from my experience in the Coast Guard is having in a database all of the pressure vessels on large U.S. flag ships, and we knew the status of them and when they were due for internals, and also the monitor on the corrosion. And so with that background, I was expecting something similar, and then came to the oil and gas industry and found that it was not necessarily so. We were looking and we found a big difference in how companies managed and kept track of their pressure vessels and the required maintenance. And one of the toughest things to do is to try and keep up with the periodic internal examinations. And many companies feel that their non-destructive testing methods are adequate for determining thickness and corrosion rates. However, there are problems with pitting, and particularly at penetrations, nozzles, and so on, washed out welds or corroded welds because of material problems, and the external non-destructive testing may not give you a complete picture of what you have. So if you read closely the ASME PI recommendations on repair and maintenance of pressure vessels, you'll see that there are some requirements for internals to back up your UT programs. And you need to stay on top of those because those will come back and can cause you a problem. You want to keep your passive corrosion protection anodes up to date. If you're using coatings internally, you can find that if you don't maintain the coating, you can have accelerated corrosion in spot locations, and you may have a problem, not because the pressure vessel is bad and thin per se, but you have a pitting problem, and it can cause you to have to get in there, inspect, and even do repair. And once you have to go into shutdown, open the thing up, clean it, and so on, it really matter how expensive the repair is. If it could have been avoided, you could have saved a lot of money. So that's one of the ones. Servicing fire protection equipment, even the portable fire protection extinguishers, servicing PSV valves, all of those key items that you should have in your maintenance program. And it's really best if you have that helping you plan your major maintenance shutdowns, because that's when you need to get inside your tanks and vessels. That's when you can safely remove your Ps because there's no pressure in the system and you're safe from lockout, tagout. If a contractor is used in parts of your maintenance, you still need to have that information available. You need to have a schedule, and you need to know that his schedule is meeting the regulations and it fits and provides you what you need for SEMS. Here's some of the different ways that you can meet the mechanical integrity elements. All the way to the left is what you used to see and what you may still see. You may have someone who coordinates all your tanks and vessels. Likely with PCs, they've moved from a handwritten list of what they're going to do to maybe a spreadsheet. And in many cases, we as auditors, we will develop our own spreadsheet right from the design basis package that we're given. We will have a pretty good idea how many vessels and tanks you have, and we will try and make sure that each and every one is maintenance schedule and that it's not overdue. And once we have it ascertained that it's on there, then we're going to maybe want to look at some of the data. And we found that some contractors are not necessarily up to date on the ASME code or the API, that they think that UT will cover everything, and when they read it closely, they find, well, there should be an internal, but the company did not want to do it, and the regulator says, well, they should have been doing it. It's considered overdue. It is now an action item, and you may have to shut down early just to get that one thing done, or they may be gracious and allow you, the condition warrants, they may allow you to wait until your maintenance shutdown, but then you're going to need to get in that. That all indicates that you need to have your tank and vessel program tied in to your scheduling for your maintenance availabilities. And so what you see is you're somewhere in the green. You may use simple scheduling software. You may go from a spreadsheet of your tanks and vessels, and you may identify the 5 pieces that need something at your next maintenance shutdown, and then you'll have your maintenance scheduler go in with his scheduling, and he'll do work orders for the next shutdown. That's only as good as the memory and the coordination between. And if one of them is not on top of his spreadsheet or schedule, it lets you down. If you get it all programmed into a computerized maintenance system and you get it done properly, it will pop. It can be set up to pop binders, to trigger the different inspections that you need. It can give you reminders that your contractor needs to be coming out to do UTs on several of your vessels, or that they need to come out when you do your maintenance availability. You may need to give them a call so that he's coordinated. You might even set it up so that it notifies it. So you can see that at this point, some of these key functions, that's a lot for a human member, but the computer can do a pretty good job of it. And if you let it, it can move over to the yellow. So the yellow, the web-based, if you are coordinated with your contractors, then they may be even able to send you back electronically the different reports. Electronically, you set it up and send it to the file, and you may have a large portion of your safety and environmental design package may be electronic. You may be able to package it all up and be able to send much or most of it to the auditors in advance electronically. They may be impressed with that. It may cause them problems. They may just want the hard copies. I know that carrying large blueprints that are, 2 foot by 3 foot around on a platform is not the easiest thing when it's windy or rainy. And so, typically if you've got P&IDs or whatnot to carry around, 11 by 14 is about the best. It goes in a backpack and does not have to go on the swing rope or the billy pew on the person. They'll send it in a backpack. Oops. Mechanical integrity is really like a design cycle in that it's not just the maintenance for each piece of equipment and getting it done, but there's procedures involved. There's different management. How are we going to do it? Are we using a CMMS? It ties in the thing for the operators. If they're doing certain parts of your maintenance during their workday, or you have some maintenance staff, electricians in-house, you're going to have pieces from your mechanical integrity program that form some of the basis for your training. Beyond that, some of the leaders will have to do with your device testing, your safety system testing that's done on a periodic basis. It may be witnessed by the regulators, like we do in California. And then beyond documentation, what are the reports from the corrosion monitoring that comes out to do your UTs? How are your PSV servicing documented by the contractor, and how do they get you the information, and they are doing some type of analysis on it, or are they expecting that your facility engineer is going to look over service records or your tank and vessel information, and your facility engineer is going to decide that you need to do coating renewal? They may not be providing that for you, and it can come to bite you in the wrong end of your platform. And finally, feedback on your mechanics. Is it meeting what you need? Are adjustments needed? Is it finding that you have certain types of maintenance problems with a particular brand or type of equipment where it may initiate a MOC? You may want to change equipment and so forth. It's constantly evolving. As you put systems on and some of these things that are different regulatory criteria that have been a problem, you may want to consider that as a critical part. It helps where you have maintenance and repairs that keep reoccurring. It helps you identify critical spare parts that you need to have on hand, and that ties in with some of the other pieces of SEMS. So this thing is cyclic and it evolves. Just say, I am ready for Steve and
Mark.
Yep,
Thank you very much. Actually, if you can give the mic to Esther, what I'll do is I'll give her a little introduction, and we'll go from there. All right, Mark, thank you very much. And what I'd like to do is then introduce Esther Brawley. She's a senior management professional. She received her BSME at the California Maritime Engineer on commercial ships. She's played a key role in 20 studies of all sizes with training, development, management of these safety management systems to address the various overlapping regulatory requirements And one of her specialties also is HAZOP studies, the hazards analyses, and drilling down to get to the bottom of what makes these programs work. So let me turn it over to Esther Brawley.
Thank you. Okay, so obviously we have about an hour, hour and a half time, so there's a lot to cover. We've kind of put more content than we're really going to spend a lot of time on in your presentation that was emailed to you. So don't be surprised if some of these elements, they tend to be a little bit more self-explanatory. I'm going to gloss over and not necessarily cover every bullet. So job safety analysis is technically part of the hazard analysis element of SEMS. This is kind of a new animal. It's not a requirement for onshore safety management systems such as PSM or EPA RMP. So this is just specific to deep water offshore. One thing you need to notice, though, is that first bullet in the regulation 250.1911B, which says you need to have a JSA for all activities in your SEMS program. There's been a lot of debate and questions about that. Not really very clear guidance on what that means when you say all activities. But it's pretty safe to say that definitely all of your operating procedures need to be covered in some sort of on-file JSA, and obviously special operations and inspector operations, whatnot. I think really the initial test is to just grab and, if I were auditing and I wanted to kind of get an idea of the overall functionality of, the JSA program, I would probably grab a handful of operating procedures and then ask to see the JSA that's on file for that. I would also probably start interviewing people and try to get an idea of their understanding of when they need to do a JSA. One of the best techniques you can have when auditing is, kind of put the paper aside for a second, do the checkbox later. You're on site, you're talking to people, you're able to take up some of their time. Use that time to interview and really get to the bottom of asking people, different people, do you know, what's your understanding of when you need to do a JSA? What's your understanding you need to update an existing JSA? How do you access the information? Where are you filing it? That's you the overall big parent. Is it synchronized? Is everybody doing the same thing? Ask one shift, then ask the other shift. They're probably doing something totally different. So take the time while you're on site to really interview people. Then get down into the drudgery of going through all the papers and checking off the boxes for the paperwork. And then obviously, this is basically what should be in a job safety analysis. Okay, training. Obviously, this is a very important element of SEMS. It's not just training for your personnel, but also your contractors. These are the general requirements. The first thing I like to do when I'm auditing the training program is I like to put the paper aside. I can sit there by myself in a room and, go through all the documentation and check the box. I'm on site. I have, these people's valuable time available to me. I want to ask them questions. I want to interview. So the first question I ask is you just, go to the individual that you think or you've been told is responsible for this and say, hey, give me a list, spreadsheet, training matrix. I want to know all the names of the personnel, their job classification. I want to know the training titles that job classification of that person is required to have completed and the frequency. And I want to know you have a bird's eye view of this. And the date of their last training. Now, obviously, if somebody can't materialize a list or a spreadsheet or a matrix or a program or something quickly, then my next question is, okay, well, if you don't have that, how are you tracking everybody's training and that it's been completed? And who has ownership of that? Who is the person who has ownership of tracking everybody's training and their frequency and that it was completed? So once again, I just like to get into the interview process and get an idea of what's going on, what are people doing, and how is this working. And then the next step is obviously to go and gather all these little fragments of records that are, stashed in different people's computers and file folders and whatnot, and then start, you know, combing through it and comparing it against the personnel to make sure everybody's okay. But the basic intent of the training element, you have a deficiency there. That is a breakdown in that program. It's not working because you weren't able to quickly, you know, if somebody asks, and not necessarily an auditor, but just someone in your organization, you're not properly managing that as a whole for your whole organization. And that's the main issue. Same thing with contractors. So we need to have that information for your own personnel, but we also need to have that information organized, summarized, and easily accessible for your contractors. Pre-startup safety reviews, pretty self-explanatory. Obviously, as Mark said before, when we start finding threads, so we start seeing changes in your process, equipment. He mentioned, you know, newer steel, obviously newer vessels. Then you take the thread and you follow it all the way through. So then you start looking for MOC. Then you start looking at IDs, PFDs, safe charts, mechanical integrity program. Were they updated? Were people trained on it? Were people informed of the change? And then the final part of that thread would obviously be whether the pre-start safety review is completed for those MOCs. Emergency response and control. This could be its own separate webinar topic or workshop. Just the basics of what we see that's not up to date. The biggest thing I want to cover is when I audit people and they have a paper manual. And then the first thing I'll ask them, just, you know, as part of interviewing to get an idea of the functionality of the program is, do you even have electronic files for this? They can't even update it if they wanted to. You know, you're scribbling, you know, crossing out names and numbers and writing in the new one. And so that right there is a red flag. You need to task somebody with creating an electronic copy of your emergency response documentation, and then and the usability of it too. You know, it's either too big or too lean, so resolving that. Okay, incident investigation. A lot of times auditors just say, oh, have you had any incidents in the last 5 years? No. Oh, we had one. Okay, well, I'll just look at the incident investigation for that one. And that's just not really going to let you give you an idea of what's going on. So that's why I really like to focus on talking to all the personnel, getting a feel for, you know, what is their understanding of incident investigation? When do they think they need to do an incident investigation? Sometimes people have a really bad, you know, feeling about incident investigation. They just really don't want to get involved in it. It kind of has this blame, scapegoat aspect to it, like, oh gosh, I'm going to get in trouble from this. I'm kind of indicting myself. And you need to really work with your guys to say, no, this is, take more of an emergency responder attitude about incident investigation, after action report, lessons learned, let's learn from our mistakes, let's improve, constant improvement, guys, you know, thank goodness somebody caught this, thank goodness nobody was hurt. You know, let's apply this to all the shifts. Let's inform everybody. Let's figure out the root cause. Why do we have this breakdown? And really get your people motivated around incident investigation, because it's really an important element, and a lot of people just don't. It's kind of brushed to the side, and it's like the last thing anybody has to do. And definitely want to ask people why. The incident is not just that the relief valve stuck open. You know, you've got to start, you know, asking these questions. Why wasn't the equipment maintained? Why wasn't the procedure followed? How do we learn from our mistakes? How do we improve? Do we understand the purpose of incident investigation? Yeah, once again, if there's just the slightest bit of negativity in your organization surrounding incident investigation, where people feel they're going to get in trouble, they're going to get reprimanded, there's going to be some sort of scapegoating occurring, you are guaranteeing that people are not going to do either incident investigations properly, and they're definitely not going to do near misses. Near misses will not get communicated up the channels of your organization. And these are common deficiencies with incident investigation: lack of follow-through and recommendations, not sharing all the findings with everybody. It's really important, and that's where one of the things, investigation for slips, trips, and falls, and more, you know, back injuries and things like that, differ from incident investigation for high-risk industrial processes and things, is that for PSM or SEMS, it's all about information sharing, lessons improved, whereas a lot of times HSE, you know, safety, you know, first aid injuries, things like that, that kind of goes into the file, and that's not as necessarily open. So it's meant to be shared, improvement, lessons learned, very similar to after-action reports with emergency response actions. And then once again, no investigation or documentation or even a thought of what is a near miss. I always like to ask this question, what is a near miss and when would you initiate an investigation? And most of the time, people either have no idea what I'm talking about or they, and I'm talking about, you know, ground level people, because, you know, that's what we're auditing, is we're trying to see what are the people on the ground, how is the SEMS program functioning for them? You know, if I want to have a discussion on the finer points of safety management systems with the experts industry, I'll go to the Global Conference of Process Safety. Here we're looking at, is this thing working? And obviously everyone has a different answer on what a near miss is. Okay, we need to write some guidance and give people a flow chart or some sort of a brief summary of what constitutes a near miss to help them understand when they need to initiate an incident investigation for it. These are just some examples. And just kind of put in layman terms, you know, these things happen all the time and you just don't even think about it. It just happens. It's part of normal operations. And no one stops to think, oh my gosh, that is technically a near miss. And maybe we should look into this and see, you know, what's the problem here, what's going on, and maybe we can improve or fix it. You know, and obviously liquids in tanks are not supposed to be relief valves relieving. There's any safety device actuating. You know, it's not meant to be a normal control valve or pressure regulator. It's a safety device. It's not supposed to, it's like the last layer of friction. So where were these layers? Why weren't they working? How did we get to our safety device actuating? And yeah, ESDs, fouling of equipment, etc. These are just program-wide deficiencies. And one thing I want to stress is you want to interview people, you want to kind of step back from the checklist and really look at what's going on program-wide. How is this program functioning? Some of the worst audits I see are just a checklist, and somebody just kind of puts their tunnel vision on and is looking for the papers to check the box. You're just not going to have a very good audit, and you could have some problems or some issues that could put you at risk, put your operations at risk, put your company at risk, and you just have no idea. Nobody's documenting this or even talking about it. So obviously program-wide deficiencies, no supporting documentation or proof, but you talk to everybody. Everybody knows what's going on. Everybody's knowledgeable. Everybody's, you know, really good, motivated group of people. And then it's kind of bad because they're doing a great job. They're synchronized. You know, they're motivated. And then, but they would miserably fail an audit because we don't have the proof. We don't have the papers to prove they're doing all these things. And then the other thing is you have these great papers, but people just have a complete lapse of the SEMS program, and they kind of view it like this, you know, management dictating that they fill out all these papers and they just have a breakdown and are not on board with the SEMS program. It's management and corporate program, but it's not the guys on the ground program. So there's a disconnect there. And then obviously the biggest thing I see, and please don't fall into this pitfall since we have the new SEMS regulation. This happened in PSM and RMP, where you would get there and it would just be this elaborate program. It was very nice and pretty, and you could tell they paid a lot of money for it. But then you just look at it, and then you'd ask the guys, okay, well, what do you do? And then they show you, and you walk around with them, and you do the audit, and then you come back and look at the binder, and it's, I don't know whose program that is. It's somebody else's, but it's not what these guys are doing. And then the other thing is, or you look at the program, and it's just the regulations regurgitated in a prettier format. There's nothing there. There's no procedure. It just says company XYZ must have procedures that meet these requirements. And then you're like, okay, that's great. So, and then Where's the procedure? Where's the maintenance program? Where's, okay, I just relations again. So just watch out for that. Needs to be real-time documentation. This is something I really want to stress for the offshore industry. I think people onshore can get away with the paper and make it work. You know, it's not the best, but you can make it work. But you guys really need real-time documentation, electronic, you know, just get in the habit of, you know, taking the stack of training records, stick them in the scanner, and then email them or save them onto the server. Get in the habit of organizing your documents on a server, electronic. If you can do web-based, that's even better because now people from land, corporate, can like log in and view it. People on the platform can view it. Contractors can view it. It's just better to have electronic and just get away from the paper. And plus, it's a nightmare to prepare for an audit. I mean, you're just going to be hating yourself preparing for this thing and grabbing all the papers and running around into all the people's file folders and computers. It's just horrible. So get going electronic. Recommendation follow-through is just always a big one. Remember, the worst thing you can do is you have your PHA recommendations over here in this report, and then you have your compliance audit recommendations over here. But you could have 2 or 3 compliance audits. So now you have recommendations scattered across 3 different reports, and then you have some instant investigations and their recommendations. You need to compile all that into one database, Excel spreadsheet, whatever. Those reports are all a record in time, like on such and such date, we did this audit, these were the findings. That's not the place to be tracking and closing your recommendations. That report is a record, and we need to pull those recommendations out and put it into something that we can track, close, set target completion date, update in real time, and I would strongly suggest a database or a spreadsheet at a minimum. Because if I'm auditing, that's the first question. How are people being reminded? Who's providing general oversight? How are we regulating the failure to close recommendations? Can I see a list of all your open recommendations? You should be able to materialize that pretty quickly, because if you can, then you're obviously not tracking it. If you're having to dig through 10 reports, that's a problem. That's a breakdown. And then once again, this is kind of sad. A lot of times people do close out their recommendations. They install devices, sensors, whatever. They go to all the trouble to do it, but then they don't go back into the trackingism, spreadsheet, whatever, and say, close such and such date, this is what we did. That's still a deficiency because you're not upkeeping your documentation. You're not organized. You're not keeping up your SEMS program, even if you did all the recommendations and completed them. You got to, when you are documenting the closure of your recommendation, or especially if you switch, like, you know, teams do the best they can to come up with an idea of, okay, how are we going to address efficiency? Here's our recommendation. But sometimes after the study's done or after the audit's done, you evaluate it and you're like, that's not such a good idea. This is a better alternative, or that kind of defies the laws of physics or best engineering practices. That's not feasible. We need to do this to address the risk. These are kind of industry guidelines for when you can decline a recommendation, that you really need to have very good documentation and justification on why you did not do that recommendation. And I really put down there, infeasible does not mean expensive or difficult from a logistics standpoint. It really does need to mean defies laws of physics, defies good engineering practices. You know, the team did the best they could, but you know, their idea wasn't very good. This is probably what we should do instead. And the other thing is you really need to provide backup documentation as well. And the biggest thing too is that if you did hazard analysis, sometimes you might be able to decline a recommendation because it wasn't risk driven. And so you can say that, you know, this wasn't risk driven. This was the scenario. The team thought it would be a nice idea to do this, but it's not risk driven. The same goes with declining a recommendation. Somebody identified a risk, so that risk has to get driven. So regardless of if you go forward with that recommendation or not, somehow you have to address that risk that was identified. And then, so from effectiveness, I'm just going to skim through these really quickly. But basically what this is, okay, you have the checklist, you did the audit, are all the papers here, all the T's crossed and the I's dotted. That's one aspect of your audit. The other approach, though, you need to take is really looking at program effectiveness, the safety culture, people's understanding of it, you know, all levels of the organization. Are they all involved here to see how your program's working? And then take that time, that valuable opportunity you have to be there, talking to everybody, working with the different shifts to get their back and suggestions on how to improve. Because if you miss opportunity, the thing is that, you know, a lot of people look at lost time injury statistics and things, but usually the common analogy is that process safety indicators, the things leading up to a major catastrophic accident or release, everything was below the surface. There was all these really minor, like, work orders or near misses that were just kind of chalked up to normal operation, and they never got brought to the surface until, you know, a big accident occurs. So these are just examples of process safety indicators, things to look at, things to ask, question your personnel when you're on site to see if this is going on. The biggest thing is people are not human control valves. So if you have control valves in your system, pressure control valves, temperature control valves, level control valves, they're meant to control. If they're not working and you're having to use a human being in their place, that is a process safety indicator. You probably want to look into that. And let the guys know, like, we need to do something about that, because that's the big one. And then these are just another example of other process safety indicators. So be looking for, talking to people about, asking people about while you're out there. Implementation tips and safety culture. Get past the checklist. The checklist is going to get you 40, 50% of the way there. It's really talking about the people getting to the bottom of the safety culture, forms and procedures just at the beginning, talk to the non-managers. Yeah, reduce hazards and risks through changes in your underlying safety culture. And just remember, and this is something I always try to remember to tell people, because sometimes people get kind of defensive and there's, you know, what's going on here? I'm getting interrogated. And I'm just trying to say, look, everybody knows nobody wants to kill themselves. Nobody wants to hurt their coworkers. Nobody is, you know, rebelling and insubordinate on purpose. Like, let's all work as a team. This is a multidisciplinary program. It's a team-driven program. No one's getting blamed. We're not pointing fingers. Let's just, the past is the past. Move forward. Let's improve. Move forward. I don't want to even get into finger pointing or blaming. I just want to find the root of the problem, solve it, work together. You're the experts. I like to tell the guys, you guys are the experts. You know how to run this platform. Move forward. And then the influence. You've got to look at the influence that your management has on this. And these are just some examples. You know, if people don't have resources or time, there's really only so much they can do. So these are things to think about if you're auditing and looking for it and being realistic and objective about the impact that maybe managers, systems, and practices have on the functionality of your SEMS program. These are the major tools, and I just really want to kind of touch on what I already went into investigation and how that's kind of pushed to the side. And that's a tool to help you guys learn and improve and find things before it's catastrophic. Same with hazard analysis. Yes, bare minimum, 14B, and maybe like a little what-if checklist. But if you do a HAZOP study, that's how you're going to start finding out things like, oh, we're operating all our control valves in bypass. Like, oh, that tank keeps overflowing. Well, hey guys, what do you think about that? You know, what are our other safeguards? HAZOP is going to help you identify your critical safety devices. HAZOP is going to help you understand your consequences of deviation. HAZOP studies are going to help you determine the lock closed and locking open configuration of valves. You're going to find that valve that, oh my gosh, if somebody opened it, this is something crazy is going to happen. That's how you're going to find that is through doing a HAZOP study. So I really want you to think about, I understand people are probably going to, for the deadline, which is coming up pretty quickly, do the bare minimum, but I really strongly suggest you start chipping away at doing HAZOP studies, hazard and operability studies, studies form. And then once again, this is the thing. Management is involved here. It's an organizational, top-to-bottom program. The SEMS. It's not just a bunch of checklist forms that you dump on people to fill out. So this is an organizational program. Once again, these are the kinds of things you need to be asking when you're auditing. What is the root cause of these deviations? What are the root causes? Why are we not able to get this SEMS program off the ground and functioning? Why is it just getting dumped and pushed aside and incomplete and nobody's on board? And these are some other examples of that. Then this is the closure. Stress of staff, SEMS implementation, it's a function of the overall stage of the company, all levels of organization, all disciplines. You're not going to hire a SEMS coordinator who's going to solve all your problems. That SEMS coordinator might be able to do 2 procedures a week. That goes to one of my clients who's tuning in right now, who's struggling right now as a SEMS coordinator. You might be able to knock out 2 procedures a week. You're not going to hire this guy who's going to solve all your problems. It's an organizational thing, multidisciplinary thing. Many people have to get involved, and this is kind of the life cycle. So I'm going to turn it back over to Steve, and he is going to talk to you and close up our presentation.
All right. Yes, sir. Thank you very much. Appreciate it. Okay, we'll be done with the presentations in 10 minutes, and we'll start our question and answer session at that time. What I wanted to do is kind of close this out and show you the big picture of how this is pulled together after I click the right button. Okay, so all of you who are following the SEMS regulatory requirements realize that November 15th is a regulatory deadline. It's a hard deadline, and a lot of facilities have a lot to do. There's a lot of these safety management system elements that are in common between SEMS, PSM, and RMP. I mentioned that earlier, and I also promise you that I pull it all together at the end. Basically, what you've got is a lot of companies that have onshore and offshore resources, or onshore and offshore facilities, also have resources for these various elements. Corporate level procedure and investigation approaches, people, software, other kinds of resources that they can apply to the SEMS program. The best programs are integrated. There are things where you've got as much in common as possible with respect to best practices and best implementation for all your facilities that handle highly hazardous materials. So I would encourage you as much as possible to tap into these resources, the technology, and expertise. Next one. Please recognize there's a broad spectrum of activities that are covered. Try to integrate these things, minimize duplication, recognize there are similar objectives, program overlaps, and work towards a unified program. Also, a lot of folks are still at the early stages of SEMS formulation. Why don't you start simple, use your existing elements and apply it as necessary, morph it into the new programs. Then take a look at it. Use the audit techniques that you learned from Mark and Esther today to use that, and also do a gap analysis. Find out what's missing, what parts of the program need to be done, and then, of course, prioritize your efforts. This is the real world. The fact is November 15th is coming up real soon. A lot of people are going to be behind. Go ahead and prioritize what you have to do and really focus on the things first that make a difference for the safety at your facility, and, of course, work towards getting a comprehensive program. And again, don't wait. There's a lot of things to be done. There's different resources you may need within your company, other consulting groups, etc. It's important to get those things started. So anyway, I just wanted to share with you a couple of insights in terms of how to make use of this based on our experience in helping facilities pull these programs together. What I want to do also is give you a little update on some things that are happening out there that are going to affect what you're doing and may also provide additional resources in the near term. The Offshore Operators Committee, they're diligently working, several subgroups are working to develop an audit tool. This audit tool, there are several pre-versions out there, and they're looking at an August timeframe for completing this, but it is going to be that is primarily checklist-based. As Esther mentioned before, it's to go beyond just the checklist, the framework for doing audits, and really dig down and drill into the sort of things that are driving safety performance, and safety culture at your facilities. American Petroleum Institute recently formulated the Center for Offshore Safety. Right now it's in the stage of defining objectives and the key things that offshore facilities need to do. They had a meeting yesterday, as a matter of fact, to define a lot of these key objectives. The meeting was in New Orleans. Some of the key focus areas are the same sort of things that Mark and Esther mentioned. Not only auditing and identifying what gaps there might be in your program, but also understanding the hazards. The audits and the hazard analyses are the things that are identified as some of the key things that industry is going to have to address and are going to be key focal points for the Center for Offshore Safety. And then Bureau of Ocean Energy Management Regulation Enforcement, BOMR, is working on an update to the SEMS requirements to address a couple of issues. The update is slated, my understanding is the update is slated for fall 2010, and the idea is to have increased focus and guidelines for performing these gap assessments and audits, and also secondly to identify additional mechanisms that BOMR would have to implement fines and other sorts of penalties. So yeah, that's what's been happening in recent weeks on this. A lot is also coming up, and what I want to do next is start about other resources that are available to you. While I do that, start thinking of questions. We're going to have Mark, Esther, and myself available for general questions as part of the Q&A process. And if there's any real tough questions, I have Wendy Maxwell in the office too, who can really help out. So what I want to do is identify some of the key references and resources available to you. Risk management professionals, again, as part of our outreach of our engineering consulting activities, we have covered, at this point, most of the SEMS elements in terms of webinars, where we've done live webinars that have been recorded, and those recordings are available in our outreach page on our website. This is just a simple list of them. It's basically overviews, all the different elements, a lot of the key things. One of the ones that really has a lot of meat to January 12th, we did a hazards analysis webinar that are going to have techniques that you'll be able to use as you address some of these near-term requirements for SEMS. Today's webinar for auditing, usually within about a week or so, we'll be able to post the recording. You can share that with other individuals. All these things are resources available to you. We've also got a couple other that are coming up in the near term. August 9th, we've got one for, we're going to roll together training, contractor safety management, and implementation of safe work practices. Hopefully you guys will be able to attend. These are hopefully easy for you to tune into, and they are offered complimentary. After August 9th, it's August 9th on the top of this page, but we got several others that are coming up in their term. August 11th, we're going to be profiling, a lot of you know David Embry of HRA Associates. We're going to be profiling the ProSaint software that helps you pull together operating procedures and the job safety analyses that are linked, of course, because JSAs are heavily involved on actual operator activities. And how to pull those together in terms of the software package will be on August 11th. And even for those of you who aren't in the software, it'll have techniques on how you integrate operating procedures in JSA. September 13th, we're going to have our talk about the incident investigation element of SEMS. September 21st and 22nd, we're actually going to have a 2-day bow tie course at our Irvine, California Training Center, which is where we're broadcasting from today. And that'll be a register in advance. That will be a paid course, again, focused on bow ties and the bow tie XP software package. Will be a complimentary webinar again. All these are complimentary unless I tell you otherwise. October 10th is a complimentary webinar on offshore facility emergency action plans. Also coming up in October in New Orleans is a 4-pay course that we're going to be providing. Use the elements of SEMS in more detail, and because a lot of people are going to be focused on hazard analysis, we're going to spend more time on that, and also compliance auditing and gap analysis. We're going to spend a lot more time on that. Again, that'll be in New Orleans in mid-October. The dates will be identified, and anybody who's on our mailing list will be getting an announcement for that. Also, I've included various locations on the web where you can get information. We try to post general information. I mentioned our webinar recordings and materials that can be used. You can share with other personnel in your organization. And a lot of companies, organizations like API, they're realizing the importance of their own safety guidelines and the application of best practices. And you can get a lot of these safety guidelines right off the API website. And of course, SEMS1.com has a lot of the information and links and resources that we've been gathering and can be providing. The fourth bullet is the one that we try to coordinate most of the third and fourth, bless you, all the different offshore webinars and outreach programs and our announcements for upcoming webinars. Again, most of these things are complimentary, and we use them for a variety of purposes internally too. The references, there's 2 pages here of documentation, general industry guidelines, and I guess you've had some time to think of questions, so we can go ahead and start coordinating questions, and I'll ask Esther and Mark to join me. Did you want me to start with the ones that you had posted before? Okay. One of the questions that we got was, can you outline the major new requirements that will come into place this coming November? Hopefully you've got an appreciation of that from the different elements that Mark and Esther reviewed and what you'd want to look for from an auditing perspective. Also at the very beginning of the presentation, and maybe, I don't want to get off this page. I want you guys to have lots of time to write down phone numbers and contact points for questions, but early in the presentation on page 2 of your, no, I'm sorry, on the 10th slide, which will be at the bottom page 5 of your handout, there's a pinwheel figure that identifies all the different SEMS elements. Also on our website, there's all the details from 30 CFR Part 250 that contains all the regulatory requirements too. Also, if you look at our webinar page, there's several overviews as the SEMS requirements were being developed that also provide that background. The next question was, are vessels only work near coastal and inland waters? Everything I've read up on SEMS refers to outer continental shelf and being in compliance for BOMR. Do we still have to do this, being that we only work near coastal and inland? The answer is, it's a multi-part answer here. As everything in the regulatory arena, nothing is 100% simple. Let me go ahead and start, and then I'll turn it over to Mark and Esther to elaborate a little bit. Basically, the BOEMRE requirements do apply to federal waters, outer continental shelf activities. However, different coastal areas and states currently have some requirements that hinge on safety management systems, and I'm definitely going to ask Mark to tell a little bit more about his program. And several states are currently formulating some of these requirements and maybe adopting all are part of SEMS. And so, Mark and Esther, you want to elaborate a little bit?
Yeah, part of the question addressed vessels, and of course the Coast Guard regulations are going to continue to apply to the vessel portion, and if it's operating in drilling mode, so forth, the local government is going to have jurisdiction within 3 miles, as I understand it. For California, state platforms that are inside 3 miles, we're the regulator within MMS, now BOMR, and our regulations apply. So that's why we've had this auditing program for over 10 years now. We've implemented it since then. And the question?
We don't have a SEMS deadline. You don't have a deadline.
Correct. We don't have a SEMS deadline, but in fact, we've been using the SEMP requirement as a it was a recommended practice from API, and in our regulations we require the use of good oil field practice. And so the interpretation was that many and most of the API recommended practices could be considered good oil field practice. And so we've been looking for the use of API RP75 SEMP or a similar company program. And we would evaluate a company program against RP75 SEMP or against PSM if it's an onshore facility. And so that's what we were looking for. We found that the programs to be very similar as Steve described. And in many cases, if you meet one, you essentially meet the other. You may want to look at fine-tuning or, making sure all the I's are dotted and T's, and that's where the gap analysis could come in. If you can bring your PSM type, let's say your incident investigation, you have someone trained to do incident investigation in your HES department, and you don't have it addressed at your offshore facility, well, pretty simple to identify that you will use that resource if you have an incident where, and then you identify what the criterion is where you're going to do the incident investigation using that resource. So you have the building blocks, you just have to tie it together. If you look at some of the information from BOMER, they talk about bridging documents that bring in these other pieces that you already have. They want to know where you're going to go to find it within your organization. They want it spelled out that you're using this piece, or they want to know that, let's say one of your emergency plans is actually the state required spill contingency plan that also addresses evacuation and so on. And that's where all your instructions, guidelines, and procedures are located in a particular plan. You just bridge over to it, and it may meet all of the requirements, and you have now turned that building block into an essential piece of your plan. You may have a lot more of the building blocks than you thought. Maybe not for that facility, but within within corporate or at other facilities.
No, I don't know anything about that.
That's a good question. So, ladies, do you want to read the next question?
We do have one more question. For emergency response and control, what kinds of emergency response plans should be included? And as an example, he says like spill plan, H2S plan, fire, evacuation, etc.
If you have a spill plan, if you have a plan that already exists that applies to that facility, you at least want to identify it and preferably bridge over to it unless it's somehow already addressed within within another major plan that's required by regulation for that facility. So, for instance, at our California facilities, we have a required operations manual that is required by our regulations. In many cases, they have the required operating procedures within them. In other instances, the operating procedures are a standalone document that may not have been required in the past. It may not have been submitted in the past. It is a requirement now. Some companies are finding it advantageous to bridge over to it, to leave it as a standalone document, and that way it's more convenient for them to have their operators review the different procedures on a periodic basis. So you're going to want to bridge over to things and then tie them together for your SEMS plan or as part of your program elements. Similar to that is the SPCC plan that's required by EPA, at least for onshore facilities, and it has a relationship with, in California, we have a requirement for oil spill contingency plan. They're separate and distinct, but they have a lot of overlap, and that's one of the auditing tips that you may want to use, is that read through them around the same time frame and see if they say the same thing, especially for rainwater management. If one of the plans tells you you're going to close all your deck scuppers and you're going to do this and you're going to send it to a holding tank, and the other plan says that it does this and it goes into the process stream, well, the auditors may read through those documents, skim through. They may see that and they say, okay, which is it? they're going to go interview the operator, and they may find out a third option. Well, it's not implemented there, and you do have problems. That would go on your gap analysis. So if you're looking through your building blocks, they need to match up. You don't want bricks going with cinder blocks, and they have different dimensions and don't fit together real well. So you need to get them working together.
Can I add to that? Great. No, just to add to that, we do develop a lot of emergency response plans here for folks, and one of the all the different elements that Solveig read do need to get addressed. All the different regulatory requirements that Mark indicated also need to get addressed. The best plans, as he was mentioning, in terms of things being integrated and coming together, the best plans that we've seen are the ones try to pull this into some sort of unified approach, where as much as possible, and it's never good to get 100% because your document's so big and complicated, it almost becomes unusable. But to the extent practical, trying to integrate these things into a unified plan has a lot of merits, and it makes a lot of facilitates keeping it up to date. Esther, did you want to add to that? Okay. All right, Solveig, any other questions? All right, well, in that case, let me thank everybody for their participation. Let me thank the speakers, Esther Brawley, Mark Steinhilber. Appreciate your support for providing this information to everybody. And I'd encourage you, if you do have any other further questions, please feel free to call in, and look forward to seeing you next time. Thank you. Okay,